All right, I'd like to start things off. Let's see here. I'd like to start things off today by introducing myself. Hello, my name is Lance Zurich, and I am the product manager over here for the Fisher Technic division at Studica. And I'd like to thank you all for attending. Today, we're going to be taking a brief look at two special curriculum-based sets from Studica that are designed specifically for introducing students in middle schools, high schools, and homeschools to the fundamental principles behind mechatronics. Now, both of these sets are designed for conducting a project-based class where students will be required to design and build a series of original prototypes based upon their own research and activities. And each of these sets includes standards-focused curriculum created especially for Studica by noted educator and STEM expert Tom White. So to start things off, we're going to start off where so many technology-focused presentations for education start these days, and that's with the skills gap that exists. Now, when you hear someone reference the skills gap or talk about the need for better STEM education in the schools, STEM, of course, being an acronym which stands for science, technology, engineering, and mathematics, what they are essentially talking about is the urgent need to prepare our students with the background they need to successfully compete in the job market that they are going to be graduating into. Now, in the employment market that once greeted our grandparents or even perhaps our parents, a good work ethic, a strong back, and being able to take direction might have been enough to land a good paying job where many of the technical aspects could be learned on the fly. But now students must be prepared to enter a world that is increasingly focused on programming, on automation, IoT, and rapid advances in pretty much all aspects of technology. In short, students must be able to demonstrate technical literacy and aptitude if they really hope to compete and to succeed. Now, this is, of course, why so much of the emphasis in education over the last decade has been on developing STEM skills. Every new advantage we enjoy, and this can be things like the tablets and the smartphones that we all use daily, all these advantages were created because of individuals who helped to make those advances. If you look at countries all around the globe, countries like China and India and so many others, they're making major strides in developing new technological advances, and they're preparing their own students to take their place in the future workforce. Now, here in the United States, we also need to prepare the next generation of graduates with the skills, the mindset, and the habits that will enable them not only to secure jobs, but also to help be part of that next wave of advancements that we will rely on to stay competitive on the world stage and really to maintain our stature as a world power. Now, as I have no doubt that anyone attending a webinar like this is already in agreement about the importance of STEM and technology-focused programs, let's instead now move right along to the main topic, which is, of course, mechatronics. Now, mechatronics has been called the science of intelligent machines. Essentially, it's a study that focuses on electrical systems, control and mechanical systems, robotics, the Internet of Things, and computer science. All extremely important subject areas for students to be exposed to, and all skill sets that are highly prized in today's technology-focused job market. Well, just how prized? Well, per the website careerexplorer.com, the average salary for a mechatronics engineer in the United States is currently hovering around $96,980 per year. So while, of course, the students who go on to secure these prized career positions are the ones who prepare themselves by pursuing the proper post-secondary coursework, before any of that happens, they need to start developing the habits and the career focus as early on in their education as possible, in high school, if not even in middle school. Now, the dilemma for educators, whether they're in the classroom or the homeschool environment, is in finding ways of introducing this kind of subject matter to students in a way that gets them interested and involved in the learning process, and not just memorizing obscure facts or ideas just for the sake of regurgitating them for a few tests, then promptly flushing them from their memory. No, to best help students to be successful and to really encourage them to consider pursuing further education in subject matters such as this, educators need to be able to present this material in a way that makes it relevant, which of course also means answering that eternal student question, well, why do we need to know this? And it also needs to be engaging in a way that holds students' attention so much better than rote textbooks and lecture presentations and things of this nature. It's got to be something that has visible real-world applications and where the student can get involved in doing things hands-on. Now, it's with this dilemma in mind that at Studica we created the Studica Mechatronics programs. Now, these two special sets, one of which is designed as an introduction to the world of mechatronics, and one of which is really intended to be essentially a standalone class dedicated to the subject of mechatronics. Each of these were created to provide all of the materials in one place that educators are going to need to enable them to offer a project-based class that is relevant, that's engaging, that's realistic, that's hands-on, and perhaps most importantly, which is crafted to meet current academic standards. Now, each of the two Studica Mechatronics program sets has its own detailed day-by-day curriculum document, which was created especially for Studica by noted educator and STEM expert Tom White. The curriculum itself comes as a downloadable PDF, which is available for free with the purchase of each set in any quantity. Now, this curriculum is designed to align to the most widely accepted academic standards currently in place in the United States. The curriculum is also designed for offering a project-based learning program. And what we mean by project-based is this means that solving the problems that arise in each unit will require the students to be actively involved in the research, involved in the design, in the trial and error experimentation and activities, and in the building of actual working prototypes that will provide the required answers. And students won't do this alone. Students are asked to work in small groups or teams, if you like, of 4 students each. Now, this will help them to develop the soft skills that students also need, maybe just as much as they need to develop technical skills. And of course, by soft skills, we mean things like communication skills, teamwork, adaptability, problem solving, and leadership. And finally, with the exception of some very affordable programming software, each set includes all of the physical building materials each group will need to enable it to address all of the design projects presented throughout the course of the curriculum. Now, the curriculum is designed to enable teachers of all types of backgrounds, and this includes even teachers from non-science or non-technology focused disciplines. It's designed to enable teachers from all sorts of backgrounds to have the information they need at hand to properly prepare them for conducting the activities and to increase their comfort in presenting this material to their students. Now, the curriculum is designed to be clear and easy to follow, providing a clear roadmap for student learning. Various supplemental materials are included along the way, both in link form throughout the curriculum and also collected at the end of each unit. And there are also special tutorials on familiarizing students or teachers with the building system they're going to use to address the projects presented in each of these units. The units in the curriculum are designed as a series of projects. Now, each of these projects is presented to students in the form of an engaging real-world style scenario where students must work together in small teams, again, these groups of 4 students per group, and they have to create a solution to the problem. Now, the project units each contain embedded academics, and at the end of each unit, students will be required to make a formal presentation of the prototype they have created to address that unit's real-world scenario, and to also explain their reasoning. There is a technical literacy task driven by each of these projects. As students work to address each project, they will acquire the knowledge they need through inquiry and exploratory research. Science, math, and technical skills are acquired through the carefully designed enabling activities. And again, as required by each of these projects, students are going to be asked to create original prototypes and any required programming-based solutions that are needed for the prototypes, of course, and they also have to maintain detailed documentation during this entire process. Now, as I mentioned a couple times in the presentation, the curriculum that accompanies each of these Mechatronics program sets was created especially for Studica by a man named Tom White, and you see Tom's picture over here. Tom's a noted educator who's been involved in teaching STEM and technology since the 1970s, and he's known for designing programs for both educational institutions and for industry. In fact, as an expert in hardware and software integration, Tom was pivotal in introducing things like CAD, CAM, control systems, digital control, additive manufacturing, and other such topics to the classroom. Now, currently, Tom is the Director of Technology for STEM curriculum at the globally recognized industrial manufacturing company, Siemens. Now, the standards addressed in the Studica Mechatronics programs are the most widely accepted standards currently in place in the United States. And these include the college and career readiness standards for mathematics, reading, and writing, as well as the next generation science standards for K-12 and the standards for technological literacy. And as I mentioned earlier, the programs are designed to be project-based. Now, this approach helps to answer that eternal question, of course, why do we need to know this? And where are we ever going to use this, that too often arise when students are presented with technical subjects that might otherwise seem too abstract in their purpose. Here instead, the students see firsthand why these things are necessary and they understand why they're useful. And the concept of working in the small groups to solve these projects problems also helps students to develop the high demand skills that employers look for. And these are, again, the soft skills, things like communication, analytical skills, quantitative skills, flexibility, adaptability, and of course, problem solving. Now, in this project-based format, subjects are integrated. The math is integrated with the reading, with the writing, and so on, which is ideal for any kind of STEM education coursework. And also because of the manner in which students must approach each of these projects with the research and the testing and the group give and take, just to give a few examples. This all helps to allow for a much deeper exploration of problems than traditional teaching methods might allow. The projects presented in each of these units are designed so that if you have several groups working on the same project, you should also see variations in the prototypes and solutions that are presented. Now, this can be, of course, because of creativity on the students' part or differences in the research and the approaches taken by each of these groups. But in any case, students get to see firsthand that problems can have many different answers, and that often there's not only one right answer, but there can in fact be several right answers. Each project in the curriculum presents students with the opportunity to plan, to organize, and to conduct research. The enabling activities that students are asked to engage in provide them with the skills and knowledge that they need to draw on to complete each project just in time. And students will be required to do extensive research as they complete these projects. Research that is utilized in the design, the prototyping, the testing, the evaluation, and the redesign phases of each of these solutions. Once again, the Studica Mechatronics sets are designed specifically for students to work in groups. Each set contains enough materials for teams of 4 students. The team approach, as stated before, helps, of course, to promote soft skills such as communication, the ability to work well with others, and leadership. And the sets offer an easily scalable approach. Just divide the number of students in your classroom by 4 to determine the number of sets needed for each class. And again, everything you need to conduct the program, with the exception of the programming software, which can be purchased in either single user licenses or very affordable school site licenses, is included inside of each box. Access to the free curriculum download is included with the purchase of each set in whatever quantity you purchase it. And also included are all the building materials which students will use in the creation of each of these prototypes. And these materials come from the unique Fisher Technic building system. And among the components included in each of these sets are 2 robotic controllers, such as you see on the screen right now, and 2 power supplies. And as Fisher Technic may not be familiar to all of you, let me provide you with just a little bit of background. Fisher Technic is a flexible and innovative construction system, and unlike other popular construction sets where they're designed to simply stack, Fisher Technic was created with more of an engineering mindset. By this we mean that the core building block in the Fisher Technic system, like the examples you see on your screen now, is unique in that it allows attachment from all 6 sides, and because of this it allows for almost limitless design possibilities. Now, there's many specialized parts that are designed to slide together and lock in place, and because there's these hundreds of different parts that are included, it will also help students to address very specific design needs. Fischer Technic was originally created in the 1960s by German inventor Arthur Fischer, who's noted for countless innovations used in the construction and the automotive industries. Mr. Fischer, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides Fischer Technic, Mr. Fischer was the inventor of synchronized flash photography, and that was back in 1949. And he was also the creator of the expanding nylon wall plug, which is used in conjunction with a screw or a bolt to help anchor heavy objects to walls. And his company, the Fischer Group, employs thousands of workers worldwide, producing many variations of fastening devices used in building construction, as well as components used in the automobile manufacturing process. And they are also known for providing consulting services related to automated processes. With that all being said, let's begin looking at each of the two individual sets. Now we're going to start off with the Studica Introduction to Mechatronics Program set, or for those of you who like acronyms, you can refer to it as SIMP. Now this set was designed to help provide a well-rounded, comprehensive introduction to the core concepts of mechatronics. Each set includes access to a free download of a 242-page curriculum document entitled Mechatronics Fundamentals, again, written by Tom White. The curriculum contains enough activity material to fill approximately 45 academic hours. Now, as such, we recommend this program set for insertion into regular related class activities, as a short class unto itself, for after-school program use, or of course, for homeschool use. The curriculum created for the set is standards focused, again using the academic standards most widely recognized in US-based education today, and it's designed for offering a project-based program. The set is designed for use in middle or high schools, or again for addressing these grade levels in a homeschool environment. Each set contains a collection of over 700 Fischer Technic building components, and this will be everything from gears and wheels and axles, blocks, sensors, and so much more, as well as I mentioned before, 2 robotic controllers and 2 power supplies. Robotic control software, again, is required and is sold separately, and we'll get to that at the end of the presentation. The curriculum for the Studica Introduction to Mechatronics Program set consists of 6 project units, and they are as follows: sketching and documentation, simple machines, mechanical systems, basic electricity, conversion and storage of energy, and an introduction to control systems. And there are also activities included to address the following areas that come up during the course of the curriculum: sketching, linkage diagrams, schematics, Ohm's law and power, pneumatics, flow charts, using the software and the robotic controllers, working with sensors such as the digital switch and the digital photo transistor, working with open loop and closed loop programming, working with digital branching, analog sensors such as the photocell LDR, working with analog branching, working with the NTC resistor and the potentiometer. Now, before we go further into the structure of the curriculum, let's first double back and look at what is covered in the second set. Now, the second set is the Studica Teaching Applications of Mechatronics Program. The acronym for this set, for those who like acronyms again, is STAMP. The set is designed for those educators and homeschoolers who wish to provide a more in-depth exploration of the fundamental aspects of mechatronics. The set includes access to the free downloadable 401-page curriculum document, in this case entitled Mechatronic Applications, again by Tom White. The activity materials in this curriculum document, when used in conjunction with the contents of this set, is designed to fill approximately 180 academic hours. So what we mean by that is essentially this set can be seen as a more expansive version of the material touched on in the previous set, and is designed for those educators who are able to dedicate a daily class period of approximately 50 minutes a day, 5 days a week, or the equivalent, every week for a full academic year. Again, this set is designed for offering students a standards-focused, project-based learning experience, and it's designed for use in middle schools, high schools, or for addressing similar grade levels in a homeschool setting. The materials in this set, the physical materials, consist of a selection of over 1,200 Fisher-Technic building components. And once again, this will include a wider range of gears, blocks, sensors, axles, and many other technical parts, as well as 2 robotic controllers and 2 power supplies. And again, software is required for this set and is sold separately. Now, there are twice as many project units included in the Studica Teaching Application and Mechatronics Program set as with the previously discussed set. And this will include units on the following: sketching and documentation, simple machines, mechanical systems, basic electricity, and then that's followed by project units focusing on the creation of a garage door, an elevator control, an automated pneumatic clamping system, an automatic pneumatic feeding system, a conveyor with a counter, a robotic control, a sun tracking solar panel, and a color sorting machine. And again, during the course of the curriculum, links are provided for various activity materials for students to utilize. And this will include sections on sketching, linkage diagrams, schematics, Ohm's law and power, flow charts, using the programming software and robotic controllers, working with open loop programming, working with sensors such as the digital switch and the digital photo transistor, working with closed loop programming and digital branching, learning about logic gates and combinational logic, learning about edge triggered versus level triggered, working with pneumatics, variables, robotic positions, recording positions, creating a graphical user interface, working with analog sensors such as the photocell LDR, the NTC resistor and the potentiometer, and working with data. Now that we've had a look at how each of these sets differs, their strong points, and the specific subject matter covered by each, let's now look at exactly how the curriculum itself is structured. Now, both versions of the curriculum share the same format when it comes to the structure of each of the project units, and as already discussed, each version will include tutorial materials. It's going to include activity materials, standards, and of course, supplementary materials. Now, in each case, the curriculum is also designed to be somewhat turnkey. And what we mean by that is that besides the elements I just mentioned, each unit is designed in such a way as to enable teachers from all types of backgrounds, and that again includes teachers from non-science backgrounds or teachers who aren't versed in technology. As long as a teacher reviews the material, they should be able to quickly become comfortable with delivering the material in the classroom. So once again, if you just review each unit before you present it, it should provide enough of a background, or it should have everything you need there. And there will, of course, again, be enough resources to draw on in the curriculum document. Each unit will include the following sections: an introduction, the purpose of the project, the concepts being addressed, an outline of the material being covered, the standards that will be addressed with the material in the unit, assessment rubrics, the essential question, the real-world student scenario, the daily plan, vocabulary words and terms, and resources. Next, we're going to take a look at each of these sections a little bit closer. We'll start off with the introductory section and the purpose of the project, which is what each unit starts off with. Just as you would gather from the name, this is the section that provides a brief description of the topic that's going to be explored in the coming days and activities. And this is also the section that seeks to clearly spell out to students the answer to that eternal question: why are we doing this? Well, this will tell them. The next section focuses on the concepts to be addressed in the specific unit, and these are going to be the broad ideas that will be explored in the unit and the core information that students should take from this project that will really be essential for them to understand and utilize, not just today and not just for this project, but to draw upon as they move forward in STEM fields of study and for some in STEM related careers. After this, we get into the outline. And in this section, this is where we drill down more specifically to what's going to be addressed in the unit. Now, as the example shown on the screen now is taken from a unit that happens to address aspects of programming, you will see that we touch upon areas such as the methods for writing programs, things like flowcharts and word problems, program characteristics, for example, open loop or closed loop, branching such as analog, subprograms, and so on. Now, after we get through with that, the next section that comes up are the standards that are being focused on in the specific academics in the coursework itself over here. And as you'll see, this includes standards for college and career readiness math standards. It'll include reading standards for literacy in history and social studies, writing standards for literacy in history, social studies, science, and technical subjects, the National Research Council's Next Generation Science Standards for grades K to 12, and the standards for technological literacy. Each project unit also contains rubrics, and this will include rubrics both for the specific project being covered and also general rubrics for literacy tasks. The next thing we're going to encounter is the essential question, and this can be thought of as the big picture question that will be focused on in each of the smaller individual activities that we'll be following. And of course, all the aspects of the larger project which students will be asked to complete in this section. The student scenario is where the specifics of the project are to be addressed are finally detailed, all of which is presented in the context of a real-world style scenario. And again, this is where students are presented with a problem that they must work in groups to solve together. Now, this problem will require students to design a unique and original answer, and that will usually take the form of a working prototype that they're going to have to create, along with whatever programming is going to be required for that prototype. Now, if you look closely at the student scenario that I'm showing on the screen right now, you'll see that the project in this unit has each group of students take on the role of a design team employed by a firm that manufactures garage door openers. Now, in this particular scenario, students will have to design a specific type of control system for a new line of garage doors. The manufacturer's requirements are all spelled out. In this case, this will include things like the fact that they're going to have to include limit switches. They're going to have to meet certain safety codes that require a method for example, sensing if anything is in the way of a closing door. And they're also going to have to incorporate an automatic light. Now, as discussed previously, each group of students will be tasked with creating both a unique and an original prototype. And in this case, of course, it's the garage door opening system. And they also have to create the programming needed to control that prototype. Now, along the way, they're also going to be required to document the entire process of how they got there. And this is going to include maintaining a design notebook and a digital engineering journal. And they're going to have to notate all the research, all the trial and error experiments. They're going to have to keep copies of all designs and sketches and revisions and so on. And at the end of each of these project units, each group of students, again, will be required to make a formal presentation in front of the class, during which they demonstrate their prototype and their programming in action, much as they would be required to do for an actual client or employer in the real world. Now, after this scenario is the daily plan. And this is the section that spells out clearly, both for the students and the teachers, specifically what is going to be expected of the students, how the teacher is going to conduct that day's classroom activities, and what specific subject matter will be covered. Now, if you look at this, you'll see that some days may involve discussions, other days may involve research, or the students building small projects that are going to help provide the building blocks that they're going to draw on to complete this larger project that's being required in the student scenario. But in short, you can really think of the daily plan as a roadmap for everyone. Now, you'll also see too that along the way, as different aspects are addressed in each day's activities, such as different things come up, like for example, if design notebook comes up, or how to use the control software, or working with the controller or whatever, that there are links to sections that will provide students with further instructions and more in-depth information on each of those areas. So if they have any questions, all they have to do is click on the link and they'll find out more about what's required for a flow chart or how to use the TX controller or what have you. Now, at the end of each unit, after the daily plan, is a section containing vocabulary. And these are important words and terminology introduced during the project unit, as well as a selection of important resource materials. Now, these resources can contain a mix of different types of material. It can be carefully vetted websites and video links. It could be PDF documents, PowerPoints, and so on. And besides the project units, each version of the curriculum also includes a section devoted to learning how to use the Fisher-Technic building system. And this will include information on how the parts fit together using the pin and groove assembly method, identifying the various types of parts, from the different types of girders and blocks to working with the various axles, gears, rivets, and much more. And students will also get to build a very basic sample model to help familiarize themselves with this building system before they move on to these larger projects in each of the units. And as learning about and maintaining proper documentation is one of the areas stressed in the course of the curriculum, there's also a section which details just what defines each type of documentation listed on the screen now and what is going to be required of the students for each of these documents. And as the process of conducting project-based class activities might be unfamiliar to many teachers, there's also a section that discusses specifically project-based STEM education and its benefits. So right now, we're just going to review everything again very briefly, but this time with pricing. First, we have the Studica Introduction to Mechatronics Program set designed as a standards-focused, project-based introduction to the core concepts of mechatronics. The program is conducted with the use of a highly detailed 242-page curriculum document entitled Mechatronics Fundamentals, written by noted educator and STEM expert Tom White. The curriculum, when used in conjunction with the materials in each of these sets, will provide educators with enough material to fill approximately 45 academic hours. It is again designed for those educators who wish to offer short classes, after-school programs, or of course for homeschool use. The standards-based materials designed for use in middle schools and high schools, as well as again by homeschooling parents seeking to address STEM and mechatronics for these specific grade levels. The physical materials in each set include a selection of over 700 components from the Fisher-Technic building system, and this of course includes everything from the sensors, blocks, gears, and so much more that will be used to construct the prototypes required in each project of the curriculum, as well as 2 robotic control units and 2 power supplies. Software again is required for the 2 controllers and is sold separately. Again, each of these sets is designed to be used by a group of 4 students at a time, with pricing starting at just $699 for a single set, and with classroom size quotes, 20 students, and for classroom size quotes, 20 students and up, will provide pricing upon request. The other set again is the Studica Teaching Applications of Mechatronics Program set, and this is designed as an in-depth, standards-focused, project-based exploration of fundamental aspects of mechatronics. The program is based around a highly detailed 401-page curriculum document entitled Mechatronic Applications, again written by noted educator and STEM expert Tom White. This document, like the one for the previous set, is a downloadable PDF document which can be accessed with the instructions included inside of each box. Now, when used in conjunction with the building components included in this set, the curriculum is designed to provide enough activity material to fill approximately 180 academic hours. Again, this is designed for those educators and homeschoolers who are willing and able to offer a daily dedicated class period of 50 minutes per day, 5 days a week, or the equivalent for on this subject for a full school year. Again, the standards-based materials designed for use in middle schools and high schools, as well as by homeschooling parents seeking to address STEM and mechatronics for these grade levels. Each box contains an assortment of over 1,200 components from the Fisher-Technic building system, including again blocks, girders, gears, sensors, axles, and a lot of other cool pieces, as well as 2 robotic control units and 2 power supplies. Software again is required and sold separately, both in single user licenses as well as very affordable unlimited school site licenses. Again, each set is designed to provide enough materials for 4 students, with pricing for a single set starting at just $799 per set. And again, classroom size pricing for over 20 students is available by quote upon request. And as for the software that I keep mentioning, let me address that quickly as well. The software in question is Fisher-Technic Robo Pro software, which is graphic programming software. And this basically means that it uses a flowchart style design where various icons are arranged and students link them up and arrange them to create the programs used for each of these models. Now, it's ideal for teaching the fundamentals of programming to users of all levels, and it's especially useful for those who have no experience with programming previous to this. Pricing for the software starts with a single user license being only $36 each, and an unlimited single site school license, which essentially means that you can have unlimited users at a single site or building with this license, and that could be one computer, it could be 100, or even more if you need. And the cost for the site license is only $120 per site license. And I do have to note that these are not subscription prices and they're not annual licenses. These are non-expiring licenses that you can access and use as long as you have the software disk which comes with each of these and are able to install it on a compatible Windows-based desktop or laptop computer, currently which would be using either Windows version 7, 8, or 10. And I will add that Fisher-Technic will post updates to their website that you can download and update your software as that might be needed. So at this point, I'm going to open things up. If there are any questions, I would ask that you use either the Zoom chat window, which should be located under the ellipses on the toolbar, or you can use the question and answer window, which should be right in the middle. As I don't see any questions going through, I will go once, go twice, although if you have any, you can feel free to type them in and I will address them. Well, if you're ready to take the next step, for example, if you'd like to request a quote, if you'd like to speak to the dedicated educational representative for your state and find out more about these two sets or any of the other educational solutions that we offer, including many others from Fisher-Technic, you can simply call us toll free at 888-561-7521, or if you prefer, you can also email us at info@studica.com, info@studica.com. And if you have any specific questions about anything I've discussed, or maybe something you wish I would have discussed today, or if you have any questions about anything Fisher-Technic related, anything with the Fisher-Technic education line of focus solutions, or with their simulation models, or any of these things, you can also email me directly. My email is lance.zurek, that's lance.zurek @studica.com. And I will be happy to answer any questions you might have. On that note, I'd like to thank you all very much for taking the time to attend today's presentation. We very much look forward to speaking with you soon. So have a great afternoon and stay safe.